So in terms of calculus, what is derivative? The slope of the function. See, the logic is this. Your formula is f dash x is equal to limit as h tends to 0 f x plus h minus fx
over x.
over h.
Oh, so yeah, so x and x.
X and x get cancelled. So if I want to find f dash 3, I want to find that x is equal to 3.
Okay.
So limit
Remains h is 0.
H tends to 0.
It just becomes f of x
F
plus
of
3, f of 3 plus h
minus
minus f of 3.
So that is limit as h tends to 0. Now what is f of 3 plus h?
So
2
3 plus h square plus 3
minus 2
here
upon h. So that is limit, maybe expand it, 2 into 9 plus 6h plus h square plus 3 minus, how much is it? 9 to the 18, 18 plus 3? 21. You have to go on writing this limit as h tends to 0.
Okay.
Otherwise they cut your marks.
Okay.
So 9 to the 18, 6 to the 12h
plus 2h
plus
square
2h square
minus
plus
18,
3
minus 18.
plus 3 is there,
But say when you are
minus 21. Yeah, you can, yeah. So this is minus
then
18
you
plus
cancel
18,
it.
cancel it, yeah, upon h. Now you have to cancel that out. You remove h common,
So 12 plus 2h.
12 plus 2h.
And then you put
Your h we can cancel.
yeah.
Now limit by substitution, 12 plus 2 into 0.
So I got the same thing as yours.
No, but you won't get the same marks. Is that if you do the first principles over here, your derivative will come to 2x.
Okay.
If you do for this procedure, you'll get your derivative
2x plus 4.
3x square.
3x plus. Okay. So do we remember this pattern?
I'll tell you. So basically, if your function is x raised to n, your derivative would be
n minus 1.
yeah, nx raised to n minus 1. So the power comes in front and this value decreases by 1.
Oh,
so therefore, you
so
have.
How does that happen?
Huh?
How does that look? How does it look?
Yeah,
graphically also.
Graphically, you think of the pattern. If you x square, it becomes 2x. The power jumps in front and reduces by 1.
So 3 and then
3 jumps in front and reduces by
4 so 4x cubed for x raised to 4.
You can do with this derivation with binomial expansion also. But you
We've never done binomial expansion.
So don't worry about it right now.
Okay.
So right now you have to accept this results. But only when they ask you first principle, you have to do the entire method.
Okay.
So if they don't ask you first principle, how will you do this? What is the derivative?
So 2x plus 2x.
So what is the derivative of x squared? 2x.
So 2x plus 4x.
2. And what is the derivative of x?
X raised to 0. 1.
1. Correct? X raised to 0. So 1. So my final answer should be 2x plus 2. Even if you use first principle, this should be your final answer. Did you get it?
So I use first principle.
2x plus 2. Correct? But first principle becomes quite long. X plus h the whole square. 2x plus h. You have to expand it, cancel off.
Yeah, it was a lot more work.
A lot more work.
So anywhere you see an x square, you can put 2x.
Derivative.
Any derivative.
Derivative. This one also, first principle. If they don't ask.
This one, can you put, so because it's x raised to 1, can you make it 9 over 1?
No. You have to get the power in the numerator. So 9x raised to minus 1.
Once I do that,
then you apply the formula g dash x. Derivative will be 9 minus x minus 1 minus 1. n raised to minus 1. The power comes in front and reduce the power by 1.
Okay. Oh, okay. Yeah, that makes sense. Okay.
So 9 minus x raised to minus 2.
Yeah.
So your answer should be minus
Minus
9 over
x
x squared. Check.
Yeah, that's what I got.
So when you are applying this rule, when you are applying the power rule for derivative, you have to have it in the numerator. Okay. Same thing.
Yeah.
Find the slope is 5. You can find substitute and again there will be long. Okay, but suppose if they don't mention this, find the slope at x is equal to 5. So they just say,
don't use the first one.
so you just don't use the first one. So take the derivative directly. So what is the derivative of x?
2x plus 2x.
2x plus 2 into derivative of x is 1.
Yeah, okay. So 2x plus 1.
So 2x plus 2.
And then I
And the slope?
5, so 10 plus 2. 10 plus 2 is 12.
That's what we got, you remember?
Yeah.
On your calculator also we got the slope as 12. Yeah.
Oh, that's genius.
The different notations.
So anytime they want you to find
Yeah. First principle, out of 1,000 sums, 2 sums will come. First principle. Bus.
Well,
Otherwise you have to use this one.
But so you won't care if unless
one, 2 sums will come in your case. Right now in the beginning step.
Okay.
I'm talking of ultimately. So there are many different notations for derivative. The most common ones are listed below. Y dash is y prime. Nice and brief, but does not name the independent variable. dy by dx.
Why is that not necessary?
Yeah, sometimes you want to know in physics and all, you have to know what's the independent variable.
But so like on all of these are same thing. Like if we get a question, aren't we just going to know that that's some of the derivative? Like why do we have to know this formula? Or do we have to use these? Can they ask us to give the answer in specific?
No. Yeah, dy by dx it doesn't matter. Dy by dx is also dy by dx or the derivative y with respect to x. Name both variables and d for derivative.
So when you say it, you just say dy dx.
D by dx.
Okay.
df dx or the derivative of f with respect to x.
Isn't f just y?
Emphasizes the function's name. Yeah, okay.
Okay.
D of fx dx.
So f of x is y.
D dx of f at x. Or the derivative of f at x. Emphasizes the differentiation is an operation performed on f.
This doesn't matter.
That doesn't matter, but these are the different variables.
But it's all the same thing.
Yeah.
Okay.
Now this is challenging. How to draw graph of f dash? F dash is the derivative from the graph of f. What you have to think is you have to take the slope of the tangent. You have to keep on taking the slope.
Okay, so it's 0 at a.
Slope of the tangent.
Slope 4.
So slope here is 4. At b?
1.
How do you know?
So it's written.
Acha, 1. Okay, they've given you. Sorry. Otherwise you have to guess.
If we guess.
Yeah.
So how do I guess this now?
How you guess just now is, listen, you draw a line like this. Acha, this was 4. This is more steeper. This is less steep.
Oh,
This tangent is more steeper.
Oh yeah, okay, correct.
This is less steeper.
So this will be less
So if you take this as 5, that will be 2. Basically like that. Any value you can guess. This is just for, okay. Acha, slope of C will be 0.
Yeah,
because
horizontal.
When you draw a tangent, the slope is 0.
The y value doesn't change.
Acha, now the slope over here will be minus 1. You have to think of the tangent.
Understood. And just the direction.
The slope of here is also minus 1.
Yeah, because it's relatively.
The slope of here is also 0. So that's exactly what you have to do here.
Oh, so then you just put 4,
So,
1, 0.
So 0, 0, 1, 2, 3, 4, 5, 6, 7.
You start at 4.
1, 2, 3, 4. So at 0, slope is 4. You put a dot. At 2, the slope is b is approximately at 1.5. Correct? So 1.5, the slope is what? 1. 2, the slope is 0. 3, the slope is minus 1.
4 is also minus 1. 5 is 0.
4 is what?
Oh, so 4 is also minus 1. 5 is also
4 is minus 1.
5 is also minus 1.
5.
Minus 1 also.
Wait, 1 second. 3 was minus 1.
Yeah, 3 for 5 are all minus 1.
No, 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 no. 5 is minus 1.
So even 3 is minus 1.
No, 3 is not minus 1.
How? So at D, 3 is at D, right?
No, it's not a straight line. It will be a curvy line.
Oh.
So it will be a slight variation. We are taking just random points.
Mm-hmm.
So now what is going to happen is when you draw it, okay, understandably, this is a cubic function.
Yeah.
What is the derivative of x cube?
3x squared.
So this has to be a parabola.
Right. Oh, it's just okay.
So if this is cubic, this has to be a parabola. Now, if you take the derivative of this,
then it will be
a straight line.
2, 4.
X square ka derivative is what?
So 6x.
6, so it's a straight line.
Correct. Oh.
So you can think like that.
So derivative is basically taking it 1 power lower.
Correct. One-sided derivatives. A function y is equal to fx is differentiable on a closed interval ab if it has derivated every interior point on the interval and the following limit exists. Your left hand, the derivative of the left hand should be equal to derivative of the right hand, and that's equal to derivative at that point.
That's what we do.
This part is not there for IB, so don't worry much. Show that the following function has the left hand and right hand derivative x is equal to 0, but no derivative.
Because so when you graph it, until it reaches 0, it's a parabola, and then it just becomes a straight line. So left and right side are equal.
Correct. Yeah. Now this is important. This is where your thing is. So you find derivative of a function, it will give you the slope function. So this is your 2x square minus 13x plus 5. So what is the derivative y dash?
2 into 2x.
So 2 into 2x
minus
13 derivative of x is 1 plus derivative of constant is 0.
Huh?
Derivative of constant is 0. Don't forget that. Remember that if your y is constant, derivative of constant is 0.
Oh, so any number.
Obviously, because y is equal to 4. If I give you a line y is equal to 4.
Okay, so then 5 into 0.
So derivative of constant is 0. Don't forget that. So therefore y dash
4x minus 13.
Now I want the equation at slope of tangent at x is equal to 3. You will put y dash 3. You replace your x with 3. So 4 into 3 minus 1. 4 3s are 12 and minus 1. So now you put y is equal to 2x square minus 13x plus 5.
If I put 3 here now.
Put 3 here now. They will give you the y coordinate.
So 88 minus.
So 2 into 3 square minus 13 into 3 plus 5.
23 minus
2, 9. 13 3s are 39 plus 5. 18 minus 34.
23 minus 39. That's also negative 16.
Negative 16. 8 and 6 is 14. Yeah. Correct? So this thing, so when you substitute your number in the derivative, you will get the slope of the tangent. When you substitute the number in the original function, you will get the corresponding y value. You're putting 3 here also, and you're putting 3 in the function also. But the outputs are different.
So in the derivative, you get the slope, and the output, you get the y value.
Y value. So basically, the coordinates of the point is 3, minus 16.
So you want to pause the recording?
Let me. So what is the equation? Huh?
It won't crash, huh?
It won't. Let's see. This is another record I'm using. So y minus y1, you can use it, or y is equal to mx plus c, anything you can use. So y minus y1 is equal to m into bracket x minus x1.
So this is why using the slope.
So y, So y plus 16 is equal to minus 1 x minus 3.
Okay.
So y plus 16 is equal to minus x plus 3. So y is equal to minus x minus 13. So that's the equation of the tangent.